Hey everyone, we are thrilled to be back live from Tel Aviv for another insightful panel discussion. Thank you so much for joining us today. We have a prestigious group of panelists from across the energy and space tech ecosystem that are here with us today, and they will share with you their perspective on how these two industries are converging to power the next space adventure. This event was jointly organized by Starburst, the Ramon Foundation, Ignite the Spark, and Startup Nation Central. My name is Noemi Aliel, and I'm the director of Starburst in Israel, a global innovation catalyst in the aerospace and defense industry. So first, I'd like to hand the mic over to Emma Vardimon from Startup Nation Central to say a few words.
Thank you, Noemi. Thank you. Very thrilled to be here. So my name is Emma Vardimon. I'm a strategic partnership manager at Startup Nation Central. Startup Nation Central is an independent nonprofit organization that builds bridges to Israeli innovation. We build those bridges through three main pillars. We connect global corporates to Israel by creating tailor-made delegation based on their challenges and needs. We build a long-term relationship with our clients with the goal to assist them in finding partnerships, companies to collaborate with, and the right operation model for them to establish a local presence. Another way we promote Israeli innovation is by knowledge and insight. Our main innovation discovery platform is the Startup Nation Finder, mapping all the startup companies, investors, hubs, multinational presence, communities, and academic research projects. Based on that information, we also generate various reports, maps, and landscapes. It's completely free to use and free to register as well. If you are a startup, we invite you to check you are listed on the Finder, and if you are there, that your profile is updated. This way we can bring you value. So through our partnership with the Ramon Foundation, Israel Space Agency, and Ministry of Technology and Science and the Rakria mission, we've come to realize that space is not only a new market for Israeli startups, but as well a great opportunity for R&D in very extreme conditions that will generate an impact on Earth. To make an analogy, we are at the convergence of the Wright brothers' invention of the airplane and flight commercialization. We are very excited to have been the connector that generated this first collaboration between the space sector and Ignite the Spark, the Israeli energy tech community. And I wish you all a great session.
Thank you so much, Emma. And next, I would like to invite Eshel Lippman from Ignite the Sparks to say a few words as well.
Hey guys, thank you, Emma, for your kind words. Thank you everyone for showing up today. My name is Eshel Lippman. I'm one of the co-founder of Ignite the Spark, the Israeli energy tech community. It's a great honor to actually make this event happen between two really big communities, and an event which was incepted thanks to Startup Nation Central. Ignite the Spark is a community focused specifically on energy tech technologies. We're celebrating those weeks our 2 years birthday, so it's really exciting to do the first event, Age of 2, with you guys. And it's really interesting to see the amazing overlaps between energy technologies and space technologies. If it's new kinds of PV panels, new kinds of batteries, new kinds of even ways to recycle air and store carbon, and who knows, one day maybe power plants that will power the Earth from the space. So with no further ado, I'm looking forward to hear people which are smarter than me talking. Thank you again.
Thanks, Eshel. Next, I'm very excited and thrilled to introduce you to Inbal Kreiss, the head of innovation of the System, Missile and Space division of the Israeli space industry, to speak a bit about the Israeli space expedition.
Thank you, Naomi. And it's my pleasure to share with you today the exciting mission. Just a second.
Again?
Now you can see it?
Now we can see it. Go for it.
Great. So good afternoon to everybody. My name is Inbal Kreiss, and I am the head of innovation in the System, Missile and Space division. It's a Sparks Hub Innovation. And in addition to that, I'm leading the Rakia mission, the scientific and technological mission to the International Space Station. This mission is a collaboration between the Ramon Foundation and the Science and Technology, Ministry of Science and Technology and the Israel Space Agency. And of course, together with the Axiom Space Company. This is the exciting mission of this year, 2021 and 2022. We are sending the second Israeli to space in order to dream, to dare, and to share all the technological challenges that we are willing to conduct in the International Space Station. So this specific mission this year is taking part from a private mission to a public mission and to a national mission. And in this picture, we can see the Israeli president in the President House declaring the start of this mission and all the challenges regarding this mission. It is our very exciting goal to add the Israeli flag to the international cooperation and to International Space Station, and to join all the nations that already participate in this challenge. Okay. Can you hear me?
Yes.
Okay.
I can see you and hear you.
Okay, so this mission, as we can see here, Axiom 1 is the Axiom Space AX1 mission, actually will open this year a new era in human exploration and in settlement in space. Actually, today there is 12 astronauts in the International Space Station, and the International Space Station is the largest laboratory in the universe for space technological demonstration and from all types of experiments. And all access to the space market start, of course, at space technological demonstration, and this is what this mission is provide. So together with Ramon Foundation, which is the leading the space, and the Ministry of Science and Technology, the Ramon Foundation website publish all the details regarding this mission to fly technologies on state-of-the-art and to collaborate with partners, to access to the ISS module, to create new frontiers and Israeli ecosystem that can be more innovative, and in addition to that, to inspire the future generation to explore the STEM subjects and space. So what are the big advantages or the big providing but this specific Rakia mission? It is reducing the entry barriers to the international space, international market, and enabling capabilities to perform space demonstration, because it is not so doable to use satellites. The availability of satellites or satellite builders is low. It is not actually doable to use the ISS directly. Need the international regulation and to deal with bilateral agreements and additional requirements. But Rakia mission provide access to all the facilities, provide launch support by the mission, and provide free astronaut time, which is highly, highly available. So the call for proposal was published in the Ramon Foundation website, and it was also set the first two threshold criteria for each one of the experiment. Is the specific experiment that proposed can be conducted on the ISS, and is the specific experiment can be conducted on the ISS in this very challenging time frame in order to launch till February 2022. And of course, the call for proposal overview was include the proposal scope, eligibility, and all the other technical information that is required. And the evaluation criteria was according to these parameters, according to the novel approach, the innovative, the mission compatibility, and of course, an additional very important, the educational and the outreach of this mission. So this is the scientific and technological meeting committee. We can see here representatives of multidisciplinary scientists from all the universities in Israel, as well as representatives from the Ministry of Science, the Ministry of Health, and the Innovation Authority. And of course, we have here also in this panel, Dr. Eliran Hemo, which is the payload specialist in this mission, and we are working together on all the challenges in this very inspiring mission. So if we take a look on the timeline, we can see here all the challenging timeline due to the fact that the launch to the International Space Station is going to occur in the coming February. And this month we will have the announcement of the groups that was selected and also to conduct the preliminary design review. In June, we will conduct the critical design review, and later on in July, the ready to launch design review. And we will be ready to deliver in September, October this year to the space station. And this mission elaborates how large is the Israeli space ecosystem. In all the webinars that was conducted by this mission, there were more than 1,500 participants and more than 600 companies and startups that was collaborating in this mission. And these are the results. These are the results. You can see the results of the scientific and technological committee. We get 55 proposals. 17 of the proposals were about basic science study, and 38 of them were a technological demonstration experiment. The scientific committee chose and selected 44 of them, which 30 from them are technological demonstration experiments. And what is so exciting in this mission is the diversity and the multidisciplinary of this mission. We can see here all the disciplines of engineering, radiation, optics, communication, agri-tech, agriculture, astrophysics, quantum communication, disease researchers, ophthalmology, renewable energy, all types of propulsions and engineering. All of these subjects were included in the selected proposals.
Inbal, we have to wrap it up.
Okay, so what we are willing to share in addition to the multidisciplinary, that this mission will combine science, technology, and education, and will support the innovation nation, achievement, collaboration, creativity, leading innovation, and technological breakthrough. And good luck to all of us, and this is a very exciting year for all of us. So thanks.
Thank you so much, Inbal, for sharing this perspective, and we are all excited to see the next Israeli astronauts to conduct those very interesting research mission. So thank you for really boosting and supporting the space ecosystem. Next, I'm very happy to introduce Francois Chopard, the CEO and co-founder of Starburst. He will share his perspective about the current trends we are currently seeing at the intersection of energy and space tech. Francois, the floor is yours.
Yeah, thanks, Noemi, and I wanted to thank our partner for this conference between Ignite the Spark, Ramon Foundation, and Startup Nation. It's great to partner with you guys on the ground in Tel Aviv and connect the Israeli ecosystem to our other hubs, whether they're in Europe, Asia, or in the US. Again, I'm not an energy expert per se, but I'm much more familiar with the space sector. Of course, energy is a key enabler, and space has been an amazing field to experiment, develop, and test new energy technology. And that's what I'm going to talk about, as well as what's happening right now in the space industry. We've seen so many startups popping up, especially in the US. A lot of financing coming around, not just in SpaceX, and it's a brand new trend and a brand new era for space techs and space startups. And we want Starburst to see more startups coming from Israel in that area. Israel has been such a great startup nation. We think there's a huge potential for Israeli entrepreneurs to develop more tech for space. So again, space has been the home bed for a lot of innovation through NASA in the 60s, while they were running their massive efforts to launch human into space, to launch satellites, go to the moon. Of course, it was a race with the Russian that ended with the end of the Cold War. But what we are seeing right now is another type of race. 60 years later, the race for space is on again. We are seeing so many nations who want to have access to the international space stations. Of course, Israel is one of them. But we are seeing also the UAE wants to launch their own astronauts. We are seeing India with a very strong space program. Korea and Japan are trying to keep up in the race. Of course, China and the US are the two main competitors. And Europe with Ariane 6 was leading the way. And as we've seen in the last 5 years that SpaceX has catch up with them and as recently took the lead. But basically, is what we are saying is that it's not just a race between the US and Russia. It's a global race. Every country realized that they want their own ecosystem of startups or technology, of larger corporations, and so everybody is investing a lot of money right now to develop their own competencies and their own engineers and their own technologies. And it's interesting, what we've seen in the last 12 months has never been seen before. We used to have SpaceX as a unicorn. We've now a valuation of more than or close to $100 billion, mostly due to their new telecommunication constellation, Starlink. Of course, they've been dominating with Falcon 9. The launch industry, but what they have developed and launched for their telecommunication constellation is probably game-changing. It's already working. They're already selling, internet access. They're already selling the antennas, and it's already available in North America to the general public. So SpaceX has led the way for the space revolution, but we have seen in the last 5 years and more recently the last 12 months, much more company becoming major unicorns. And with the SPAC boom, I'm not sure if you heard about that. It's a financial tool in the US to raise a lot of money, acquire a startup, and have that startup listed on the NASDAQ or the New York Stock Exchange. We've seen many announcements. And from only 2 unicorns, we have now more than 12 unicorns. So We have 4 or 5 unicorns that are doing launches. So besides SpaceX, we have Rocket Lab, who's going to go public, the startup between LA and New Zealand. We have Astra. It's a new launcher based out of Oakland, San Francisco. We have Relativity, Space, who is doing 3D printing rockets. We have Firefly, we just raised, 200 or 300 million. So it's not just one player, but it's much, much more. We've seen the same trend in the Earth observation market and the satellite communication market, with more startups, raising more funds and going public and reaching the $1 billion mark. And that's what does it mean? We say, okay, great, the Americans are leading the way, but what does it mean? What it means is, from a financial standpoint, the time between a startup has been created and the time when it goes public or it will reach the $1 billion mark has reduced drastically. We used to say that space, was not accessible for the regular entrepreneur, the small startups, but it's not the case anymore. Between 0 to 1 billion, we have startups that are, take them less than 5 years. Between the time when you start your company and you're able to launch your products, either on the space station or directly in space, is shorter and shorter, and it's cheaper and cheaper. Falcon 9 has reduced the cost of launching by a factor of 10. And Starship could reduce, that cost of launching by another factor of 10. So it's a pretty big deal. The access to space has become cheaper, and it's not the area where NASA is dominating everything and deciding everything. It's mostly based now on private investments and private initiatives. And as we've seen in the past, like 60 years ago, solar panels were developed, for powering satellites, as the sun was mostly the only energy out there. And so it was started in space, and we know the effects, or what has been the story of solar panel, how they were able to improve the efficiency, reduce the costs, and now we see solar panel everywhere. Lithium-ion batteries also were developed for space, first on board of large communication satellites, and now after 20 years of development for the automotive and now for the aerospace industry, lithium-ion batteries are massively used on Earth, and it's becoming a huge billion-dollar market, or much more than $1 billion. It has been the same for fuel cells. Hydrogen fuel cells were developed in the 60s for space application, and now it's becoming much more popular for automotive, and we're starting to see that for aviation. We've seen also many nuclear power plants as a source of infinite source of power for satellites, and that is currently mostly used for interplanetary exploration, because such a huge source of power. And now we are seeing, one of the main sources that could be used on the moon is helium-3 molecule. It's not sure that there's rumors that we could have lots of that gas on the moon, and that could be used for nuclear reaction to provide power. Again, if we could develop that new source of energy on the moon, maybe bring it back, on Earth, that could have massive implication on how we produce energy in a green way, or at least in a less carbon way on Earth than what we use now. And so, with all that money being poured in space, or at least on space startups, what we are expecting is that what would used to take 20 or 30 years to being developed, what used to cost billions of dollars to being sent to space, is going to take much less time, and it's going to cost much less. So again, space is becoming the hot place to develop new technology, to mature technology, and bringing back these not just experiment, but these new products and new technology back to Earth. Again, it's very exciting. We've been investing in space startups, and we are looking to invest more. But of course, we are looking at investing in all the enabling technology that are allowing space to be so efficient. Energy, of course, is a big part of this. One of the startup presenting later on, developing solar panel with new efficiencies, came from one of our program. We also invested in a small nuclear power plant for space, and we are looking for more opportunities, more startups to both invest and support in that race. And of course, Tel Aviv and Israel is a great place to look for these startups. So entrepreneurs, look at go back to universities and technologies and create more startups that we could use and invest on. Thank you.
Francois, thank you so much for sharing your insights, and I join your enthusiasm for having startups reach out to us and see what they have to offer and helping them and supporting them.
My pleasure.
Next, I would like to kick off our first panel for the evening and invite Eliran Hemo from the Ramon Foundation to moderate this panel for us. It's going to be an academic panel to speak about research in space. Eliran?
Thank you, Naomi. So good afternoon for all of us. My name is Eliran Hemo, and I will be the moderator of this panel. I'm actually the payload specialist at the Rakia mission, as Inbal mentioned, in the Ramon Foundation. I have a background on material engineering, especially on low temperature hydrogen fuel cell, like Francois mentioned. So the roads at the topic of this event of energy and space are very close to me. So now, before starting our part, I would like to give the floor to our speakers today, Professor Jeffrey Gordon and David Wiener, and to introduce themselves. Jeffrey?
Yes, thank you. It's a pleasure to be participating with this distinguished forum. I was asked to share our most recent advances in innovations in energy for space missions. I'm from Ben Gurion University of the Negev, the Department for Solar Energy and Environmental Physics, where I've been a faculty member for 43 years. The work I'm about to share with you was done in collaboration with colleagues in the US, headed primarily by Professor Chris Gibbing at Penn State University. And if I may go into, I hope that now my slide is available or not.
Yes, it's available. Just, yeah, perfect. Go for it.
Okay. The motivation is explosive growth of private commercial space missions, with the emphasis on the words private and commercial. There are now dozens of companies, and the prior speaker alluded to this very nicely. And this presents new demanding specifications for onboard solar electricity generation, because we need a combination of some really stringent demands: superior efficiency, superior specific power, which is watts per kilogram, far better compactness, and a much lower price. Part of the applied motivation for this is that the current solar cell market for satellites is approximately 10 megawatts, which translates into $1 billion based on the prices that have been paid so far. And this is growing quite rapidly. We went in the direction of concentrating sunlight for two reasons. One is it can reduce the cost substantially. The system becomes primarily inexpensive optics rather than expensive high-efficiency cells, new genres of cells beyond what are placed on satellites today. And the other is achieving higher efficiency, which is a highly non-trivial fundamental point in solid-state physics when these cells are exposed to elevated solar intensity. Our advances, which I'll show you in a moment, are related to innovative miniaturized solar concentrators of unprecedented compactness and unprecedented specific power, that is watts per kilogram. And we're using sub-millimeter super efficient solar cells. And what I'm about to show you, we have prototyped at a small scale, but everything is scalable, meaning whatever wattage you need on your satellite, we can satisfy it. And the challenge here is that concentration and optical tolerance, which is how accurately one can point at the sun on a satellite, are inversely related. One comes at the expense of the other. And in outer space, reliability and robustness is absolutely paramount. And this will limit concentration. The United States Air Force and NASA was able to quantify for us what is the optical tolerance required on satellites orbiting planet Earth. And they said, if you can achieve at least plus or minus 5 degrees, that would be satisfactory. And so our first generation was inventing a new type of all-glass mirrored concentrator, which you see here in the drawing on the lower left, with quite a liberal optical tolerance, and the drawing of the optics and the cover glazing with the microcell PV photovoltaic array is shown on the right. The entire system is 1.5 millimeters thick. Think about that. The window pane next to where you're sitting is 3 millimeters thick. So the first generation had record high watts per kilogram, exceeding what you have on the best satellites today by about a factor of 3. And we had to use, in order to do this on an immediate basis, the smallest advanced high efficiency solar cells available. You see a photo there. It's 0.65 millimeters on a side. It's a 3-junction cell. You can see what those materials are. We prototyped this. You see the prototype in the right-hand side next to a 25-cent American coin. Each of those little hexagons is one of our concentrators. The black spots are the cells being inserted as we assembled it. This was tested outdoors here on Earth with full confirmation of ray trace and thermal simulations. This was installed by NASA at the International Space Station for testing 13 months ago. We're waiting for it imminently to be returned to Earth so results can be analyzed. But we didn't stop there, and we realized we're only limited by our imagination in terms of innovative optics, and we invented a generation 2 with another factor of 3 in improving the specific power. So relative to today's systems, we're close to an order of magnitude superior. And these are tailored to new 5-junction cells, which you can see here. The ultra miniature in that each is 0.17 millimeters on a side. These exploit the entire solar spectrum. We invented a new optic, which you see here, all glass, mirrored. You see the drawing in the center, and you see the prototype, which we just finished having fabricated, and we're now testing in the lower central part. The optical tolerance is well within what NASA and the United States Air Force has mandated. The concentration ratio, the ratio of the collection area to the cell area, is enormous compared to the prior one. It's 176. And on the right, you see the first prototype in preparation. Again, the dark areas are the cells being inserted. The rest are the optics waiting for the cells to be inserted. That small module is 25.4 millimeters on a side, and it can be scaled to any power demand by assembling as many as you wish. And I would urge you to note that the total system depth of everything, cells, optics, encasement, is 1.00 millimeters. This is unprecedented for these kinds of photovoltaics. And to close, one of the wonderful points that NASA pointed out to us, they said, well, you've designed this for Earth orbit satellites, but we will find it very valuable in addition for deep space missions, because a fundamental property of solar cells is that their efficiency is penalized by roughly an order of magnitude on the lower radiance you encounter on planets, or near planets, such as Jupiter and Saturn. These concentrators restore the solar intensity on the cells to the same level they would have if they were orbiting Earth, and suddenly a new vista for delivering solar power on those missions is available. I want to acknowledge the financial support of the Israel Ministry of Science, Technology, and Space, and return the forum to you.
Oh, thank you very much, Jeffrey, for these fascinating slides. David, the floor is yours. Can you introduce yourself?
Yeah, hello, I'm David Wiener. I'm an aerospace engineer with a specialty in multi-phase flow and energy optimization. I graduated from the University of Florida, where I was working on a master's and PhD doing research with NASA on basically reducing the weight of their environmental pack and increasing the energy efficiency of it as well, in order for it to have a smaller payload going in to space. And for about the past 5 or 6 years, I've been working on an idea of mine for a startup, which involves basically energy storage that could be used both here on Earth as well as in space.
Nice, nice. Oh, so Jeffrey or David, can you tell us the difference between product development or research in space, or the difference between space and Earth from your perspective?
Shall I go first?
Yeah.
Yes. Photovoltaics on Earth today, which are basically crystalline silicon technology, is so inexpensive and sufficiently sufficient that the game is over. This is conquering the world. It's now being installed at 100 gigawatts peak per year. It will soon be at the terawatt level, totally installed on planet Earth. What we have invented, I would say, doesn't have a prayer on this planet just because it cannot compete economically. However, in space, where the mass is the critical component, as opposed to on Earth, where it's essentially immaterial. And now the combination of doubling the efficiency and reducing the mass by an order of magnitude combine to make this a superior alternative to the silicon and the gallium arsenide photovoltaics that are being installed, that have been installed and are being installed on satellites today. And this is why NASA funds my colleagues in the US, Israel Ministry of Science, Technology, and Space funds our work here. And NASA was sufficiently excited to start sending our inventions to the International Space Station for characterization.
Right, so I'll take over. Basically, from my experience, I think one of the things that people, probably in the back of their mind they know, but they don't really pay attention to, is the extremes that you have. On Earth, you don't really have, when you're dealing with research, you don't really have the extremes that you have in space. Whether it's the microgravity, whether it's radiation, all these different things that you have to take into account. And it has its benefits and also its disadvantages. One of the great things that we see is when you actually go to these extremes, you're able to find and move forward in technology, or even discover things that have always existed. Just an example, recently they found, when they dug a few miles down into the Earth, they found a life form that's actually able to eat nuclear waste. The only problem is it dies in oxygen. So these are different things that you can actually learn in space and actually take care of in space. I think like Francois was mentioning of, having nuclear plants in space. So one of the advantages is you can actually use these microbes in order to actually eat the nuclear waste. Or when it comes to energy, you can actually use that nuclear waste. There was recently, there's a startup that's trying to develop a nuclear battery using nuclear waste like a diamond layer, like micro diamonds, in order to actually generate the electricity in a safe way.
Nice, nice. Thank you, David. And before getting our last topic in this panel, just let you know to the audience, please share with us if you have any questions on the chat. So the last topic that I want to discuss on is, can you share it with the audience, particularly how do one conduct research with NASA, with your experience so far?
I am not performing research with NASA. I perform research with my colleagues in the US who are funded by NASA. So when jointly we develop a new invention, they bring it to NASA. And in some cases, NASA is enthusiastic and takes it to the next level.
David?
Right, so from my experience, it was actually very interesting, but like just an example, I remember when I was doing research in the university, I was sitting next to my professor. There was two people sitting there from NASA describing things, and in the background, my professor was playing Metallica. So these people, they're very intelligent, very very straightforward with what they're looking for, but at the same time, they're real people. So when you confront them with ideas and how to do things, they go into it to the depth, but they also have this interpersonality that's really nice. And specifically with what we did, I found a lot of openness with them. As you know, for instance, there's certain things that are classified and things like that. So when we were actually doing research, they were very willing to provide us with the information that we needed. For instance, the actual existing spacesuit design, in order to actually try to see what they did, instead of reinventing everything, see what they did in order to help them reduce the size of it and energy.
Thank you, David. So let's check if in the chat there are a few questions. No. Okay, thank you, David and Jeffy, for sharing your knowledge in this fascinating panel. And from the audience, if you have any question, you can ask us at the end of the event. Nomi, the floor is yours.
Thank you so much. I'd like to invite our next moderator, Lucas, from a Starburst Germany office, to moderate a startup panel. So stay tuned. There's more exciting things coming. Lucas?
Awesome. Thanks, Noemi. Welcome, everybody. Also from my side, particularly pleased to moderate our startup panel for today in this Powering the Future event. And yeah, very much looking forward to our panelists today, and it's with great pleasure that I have 3 people joining me. First, we have Stan Harasimanka, CEO and co-founder of Reha Solar. Then we have Jonathan Geifman, also CEO and co-founder at Helios. And last but not least, from the venture side of things, we have Lior Hellman, who is co-founder of the VC Type 5. So thank you guys for joining. And before diving now into the nitty-gritty of our panel discussion, I'd like to give everyone a quick and hot minute to present themselves and also their respective company. So maybe we can start off with John.
Yes, sure, thank you. So I'll give the aspect of the energy consumer in this discussion, as we won't produce energy, but we'll consume a lot of it in the future. We at Helios, we develop a reactor to produce oxygen, metals, and silicon out of the lunar soil, also the Martian in the future, in order to propel the establishment of a permanent base on the moon, Mars, and beyond. Thank you.
Awesome, thanks, John. Over to you, Stan.
Hello, everyone. Great to be here. So we are on the energy generation side of things. So we develop advanced space solar panels for satellites, primarily targeting satellite mega constellations and very large size satellites that need 100 times more space solar panels at 10 times lower price than available today. And we think we can achieve that by leveraging terrestrial silicon solar technology. Now, silicon is not perfect for space, so it degrades due to radiation and also very heavy. So we solve these 2 problems, and our silicon panels are space stable and lightweight, and they're also available at low cost and in large quantity.
Awesome, thanks, Stan. So now that we have the energy consumer and energy generation side of things, or production side of things, now let's talk to somebody or introduce somebody who's actually investing in these companies. Lior, over to you.
So hi, everyone. My name is Lior Hellman, co-founder of Type 5, venture capital that focus on space tech and space tech economy. When we look at this industry and the convergence that is happening between energy and aerospace, it can look a little bit odd for someone who doesn't know the industry well and not really knowing why there is such a convergence. You may think about, fuel rockets and SpaceX and the current state-of-the-art energy needs to get into space. But actually, the convergence is much deeper than that. We are in a reality today of exploiting and uncovering new technologies in the area of energy generating and energy signaling that basically empower a new area of not only space, but energy. And combining those two together, what you get is basically a new set of products that can work both in Earth and space to coexist, to transmit power to one another, whether it's from space to the Earth and vice versa. We're talking about means to transmit electricity wirelessly, of course, and also recently about super conductivity, sorry. And all of those means together coming a long way in the recent years into a new generation of products. But that is one aspect. The second aspect that we look at as a venture capital is how the current state-of-the-art energy products are becoming more efficient, more in reach, and more affordable. And our interest is basically to take companies and to take products that have the maturity and have the advancements into the market in aerospace, but also on Earth. And I know that it's a mouthful, so we'll get the panel going, and I would love to answer any questions during the discussion. So great to be here.
Awesome. Thanks, Lior, and Stan and John, of course, as well. So I'd like to pick up a few things, Lior, you just mentioned, and I think the previous speakers and panelists have echoed that, of course, as well, that the importance of the synergy between energy and aerospace, and the importance of, and also invokedness of the field right now. So maybe let's stay with you, Lior, for a second. From your perspective, what fields, from a technology standpoint, are really the most dynamic and exciting ones, in this case from an investor's perspective?
I think that the most prominent and important area that we need to begin with is actually efficiency. And what I mean by efficiency, I mean that we need to take a look at our entire chain of, from manufacturing to distribution, and to find new ways, economic ways to do things that previously used to cost millions of dollars and do them in tens of thousands of dollars. So I can share my screen here and show an example of an amazing company from the US that were basically founded by graduates of so-called SpaceX. And they basically can create in 60 days a full 3D printed missile rocket from raw material. And in the past, agencies like NASA and Boeing, Lockheed Martin, took years and years and years in developing these engines. And now we're talking about 60 days having a printed rocket ready for testing. So I think efficiency is the key word, is the bottom, the bottom ground of where we need to start from, and later on, build on the innovation, on the strategic technologies that are, evolving, and combining them with this path of efficiency and integration. So that's my take on it.
Thanks, Lior. And I think touching on efficiency here, maybe directly over to you, Stan. What is your take on this? I mean, solar panels are there's definitely some improvements to be done. So from your perspective, what are the most dynamic fields?
Well, there is no solution right now, and then people pursue different approaches. And I really wanted to discuss, why do we think our approach is kind of the best and most promising? And we have background in terrestrial solar R&D, so we've been developing product for terrestrial solar market, and our idea was to make silicon wafer really thin, and this way we thought solar cells could use less silicon, and they would be less expensive. And the problem is that you make silicon solar cell very thin, efficiency goes down, and then it's impossible to process. So we solved these two problems. We had this very thin silicon solar cell, and then at some point in 2014, some guy came to us and said, yeah, I did some modeling and I saw that thinner silicon cells can actually degrade less due to radiation in space. And he wanted, us to give him some solar cells to do some testing. And we did. NASA funded this little project. And we saw, well, what an interesting side project. And then, 2014, OneWeb announced their global internet constellation, 1,000 satellites. And then next year, SpaceX started landing its first stage Falcon 9, and they announced Starlink about the same time with 10,000 satellites. And it turned out that each is not going to be a CubeSat. It's going to be a 200 kilo satellites with roughly 3 kilowatt solar array. So we realized that SpaceX will need 30 megawatt of solar to make Starlink work. And then we thought, okay, maybe there will be several providers of global internet, not just SpaceX, maybe 5. So they will all together need 150 megawatt of solar, and the roughly 20 megawatt per year. And the existing industry can produce only half megawatt per year. So it kind of dawned on us that there is an opportunity here, and we have a technology which can potentially solve, this problem, because all manufacturers are pushing for cost reduction and they need volume. So it's kind of boom, and here we are.
Awesome. Maybe let's fast forward a little bit in terms of future technologies. Over to you, John, the same question. For you and Helios, what do you see as the most exciting and technologies out there in this field?
Yeah, so in regard to energy technologies, I mean, if we'll look at processes to produce materials, and as an example, we'll take oxygen production in order to refuel the lunar Starship that was just recently announced to be NASA's lunar lander. So this lander, according to what is currently known, will require somewhere between 100 to 300 tons of oxygen in order to get back to Earth or to the lunar gateway. We're talking about hundreds of megawatt hours in order to produce these amounts of oxygen. And we also distinct between the kind of energies, because some production processes require electric energy, some thermal energy, some combined. For instance, in our case, we require both. So it's possible technology for this issue. We see obviously solar as one way to go about it, whether it's photovoltaic for electricity or heat, or even direct solar concentration in order to utilize it directly as a thermal energy source. Another route that is, being explored is our fission reactors. Also, whether to use it as a heat source or electricity. As far as we know, these are the two main routes. Maybe there are more. Yeah, this is my answer.
Awesome. Thanks, John. And maybe here, a quick reminder to the audience, if you have any dedicated questions for the panelists today, please feel free to ask them in the chat box, and then we can address it right afterwards. And speaking about the chat, I see a lot of activity in terms of, startup founders trying to address this market here. So maybe let's quickly dive with you, Stan and John, from a founding from a founder's perspective. Why did you develop a company in this field? Why did you pick it in the first place? And also, what are your main challenges? And maybe let's try it a little bit to be a bit concise on time as well on your answer. Maybe let's continue with you, John.
Yeah, sure. So the why question is actually quite easy for me in the past year, because I became a father and I feel that I owe my son a more exciting future. And I think that would be the best answer to enable that exciting future. Now, regarding what are the main challenges and what are our strategies? So the simple answer would be funding in the long run. Because these technologies, it's a very long journey. It might take a decade, might take more. And in order for us to be sustainable during this period, we'll have to employ the technology we already developed and are developing here on Earth to do some sort of spin-off. Usually it's the other way around. Usually terrestrial companies spin off to space applications. So we're doing the opposite. We're spinning off with our space technology to terrestrial applications in order for us to be sustainable and hopefully profitable in the shorter term in order to fund the long term.
Awesome. Stan, over to you. Same question. Why did you pick that area, and what's your motivation behind it?
Yeah, I guess, in general, I'm very passionate about solar, and I found this way of energy generation the most elegant. You convert light directly into electricity using some semiconductor devices, so it works like magic. So now, like I mentioned, we saw that there is this huge demand already happening or coming up in the next 5 to 10 years, and there is no solution. And the existing energy generation using 3-5 multi-junction source cells, so it has some bottlenecks for scaling. So we see that the existing manufacturers won't be able to scale that fast. So really, there is an opportunity here, and nobody has a good solution. So there is competition. So it's just exciting fields to be in.
Perfect. Great answer on that one. So maybe now quickly turning the tables to you, Lior, from a investor's perspective. What do you look for in companies in that space, and how do you actually find these and approach these?
So Jonathan here just kind of started my answer by exactly proposing this type of thesis that we're looking for, which is the dual usage, meaning we know that just as the founders, that space exploration takes a while to accomplish, to scale, and to literally being built. And what we're looking at the most is companies that have the resilience of their technology by spinning the same solution into multiple verticals or to multiple markets. We think that by that, both the IP of the companies can be better, can be more strategic and more innovative and more cutting edge, but also in the long run, it can really sustain the ecosystem. And if we are zooming out for a moment from myself and Type 5 as a VC fund, what we want to see here in 10 years in Israel and honestly throughout the world is a space tech ecosystem that there are multiple unicorns, and around them bunch of startups developing the next generation solutions for those domains. We see it similarly happened in the auto tech industry, and I think that by combining those approaches of really getting the space, so to speak, down to earth with the dual usage strategy, I think companies can be both very attractive for investors in the medium range. I'm not saying short range, because whoever is looking at the short range can't be in space, but the mid range at least. And I think that's where we want to be as a venture capital and both as mentors for this young industry.
Perfect. No, I think that thanks Lior for that.
Welcome.
So let's have a quick look into the chat. I see there's a few questions which I think are more to be addressed offline. Avital, Noemi, let me know if I haven't seen anything or if I've overlooked anything.
No,
maybe...
that's, I think all the time we have.
Perfect.
Like that. So I think it's a perfect time to thank our panelists, to thank you and Eliran, our wonderful moderator, for this insightful panel. And thank you everyone for joining us for this virtual webinar today, for sharing your insights on how energy tech and the space tech are converging to power the next space adventure. Thanks to all of our amazing partners, Ignite the Spark, Ramon Foundation, Startup Nation Central, and the Starburst team for putting this event together. Our goal, as always, is to bring you guys insightful content around interesting innovation topics within the global aerospace and defense. So with that, all I have to wish you is Ad Astra. Thank you all for participating and have a good night. See you next time.
Thank you.
Thank you.
Thanks, everyone.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.